3.1 Level 4, use quadratic functions to maximize area. Other graphing applications, and use properties of quadratic functions to find missing values in standard form. So here we're going to take a look at this problem. The perimeter of a rectangle is 36 inches. Find the length that will produce the maximum area for the rectangle with the given perimeter. So let's first use what we know. Perimeter of a rectangle is going to be 2 lengths plus 2 widths. And in this case, we know that our perimeter is going to be 36 inches. Now we also know that area is going to be our length times our width. So what I can do is I can solve this equation here for one of my variables and plug it in like I would with a system. So let's solve for L. So I'm going to subtract 2w from both sides. 36 minus 2w equals 2L. And then I can go and divide everything by 2, so I get L equals 18 minus W. So then I can go and plug this into my formula. Area equals 18 minus W times W, and I'm going to distribute this, so I get 18W minus W squared. What we're then going to do is plug this into our graphing calculator. When we do that, our Y value gives us the area, and our X value is going to give us our width. So here I'm going to have you go ahead and look at the video provided, and when you're done, you're going to come back to this video. So once we have our equation for area, we can then go and plug it into our Y equals. So we're going to plug in 18, we're going to use X instead of W, just because that's our input on the calculator, minus X squared. And we're going to go and graph it. Now we see that we can only see a little part of it, and we know it's going to end up being a parabola, a quadratic. So we're going to have to go and adjust our window. So let's change our X max to 50. Let's change our Y max to 50 and see. Okay, we still don't have our maximum, but we have our X. So we're going to change this. Let's double it and just make it 100. Perfect. Now we see the whole graph. What we're going to do to find the maximum area is we are going to go and calculate our maximum. And so we're going to do the same thing we did in level 3. Our left bound, press enter, go to the right, and press enter, and then we guess up at the top. Now, like we mentioned before, our X value here is going to be the value of our width, and the Y value here is our area. So the maximum area is 81 feet squared. So we can write that down. Area equals 81 feet. And then we said that our width is going to be that 9. If I go and plug that in over here, I'm going to get that my length is also 9. And this is not a coincidence. The more square a rectangle is, the larger the area is. So when we're maximizing area, most likely it's going to be more of a square figure. Now in this next question here, what are partitions? This may come up in some of the problems that you'll see. A partition is when we have something that's divided and separated by another wall. So in this case, our perimeter, or what we're talking about, like if we had a certain amount of fencing, it wouldn't necessarily be the whole perimeter because we would also be counting these sides in the middle. So if we had a certain amount of fencing, let's say 300 yards of fencing, that's going to be for all of these parts. So we'd have 2W plus 4 lengths. And each of these is called a partition. So if we have 2 partitions, it would look like this. If we have 3 partitions, we would have 3 lines coming down. And that will be helpful on your practice.